Hey, good morning everyone. This is Mr. M from Algebra Lessons. In this video, I am explaining or trying to help you guys with logarithmic differentiation. In the topic of differentiation, logarithmic differentiation is a section which is very easy to use, easy to figure out the answers if you know the core idea behind this process. What is this logarithmic differentiation? That's what we need to know first. In the process of differentiation, if we have a function, say for example y is equal to f of x is a function, and if we need to find out y dash, that means dy by dx. If we have a function y and if we need to find the derivative of the function, that is y dash, and if it is not possible to find the derivative of that function directly, we can use this process or this method of logarithmic differentiation. So that is why this process or this method called logarithmic differentiation, and that is the question for the answer y. And the second question I need to answer before I am going for some example, when I can use this logarithmic differentiation in the process of differentiation or in the section when I'm handling differentiation. If you have a power rational, or an irrational function, if you have a power rational or an irrational function as a question for finding the derivative or with the process of differentiation, you can use this method called logarithmic differentiation. And that is the answer for second question. And finally, I want to explain how I can perform this process. That is very easy step or easy method. You can process a function. Let me explain with a function, general function. I have a function y equal to f of x. And suppose this function f of x is not a direct function, or the function which is not possible to find the derivative directly. At this point, what I can do, that is a question. So I'm just simply writing here as step 1. I'll come back and discuss about why I wrote that step 1 here. Okay. At this point, I'm going to find the natural log of both sides of the equation. Natural log of f of x. Okay. So natural log of f of x you have to find. So the function was y is equal to f of x, and now we applied natural log on both sides. So because we did the same process on both sides of the equation, it is not making any change for the value of the equation. So again, I am writing another item here, step 2. I'll come back and explain why I wrote step 1 and step 2. After I applied natural log on both sides of the equation, I will differentiate this. Okay, natural log, what is a log of a function? Sorry, the derivative of the log function, that is 1 over the function, that is y. But we are finding out d by dx. If the function is in x, that's fine, 1 by y is fine. But here the function is not in x, it is in y. That means it is kind of a function of a function format. So here you have to apply the chain rule. That means find the derivative of the given function, whatever it may be, then inside the parenthesis you may have a function. Find the derivative of that function separately. That is what is called the chain rule. In its base sense, that is the chain rule. Okay, we can define the chain rule in different way, or maybe theoretically we can say it in a different way. But very simply, this is the chain rule. Write the derivative of the function as it is, as per the standard result, and then consider that function, that polynomial as a different function, and write the derivative of that polynomial also. That is basically the chain rule. Okay, so here it is 1 over y, because ln of y, log x, derivative of log x is 1 by x, and y is another function, so I need to find the derivative of that too, so y dash. So 1 by y 2 times y dash is equal to, then the other side you have to find the derivative. So this is ln of fx dash. That means you have to find the derivative. Our objective is what? Our objective is to find the derivative of this function y. Okay, so what is the derivative of the function y? It will be y dash. Okay, we have a y dash here. So to get this y dash, eliminate y on both sides by multiplying y, cancelled out. So this is y dash equal to y times ln of f of x dash. Let me simplify a little more. Okay, what is this y? Y is f of x. So y dash is equal to f of x times ln of f of x dash. See, I believe you can connect this. If you need to find the derivative of a function which is not a direct function or a complicated function, what you can do basically is you need to multiply the given function with the derivative of the natural log of that given function. Okay, so we can conclude like this: y dash, or the derivative of that type of function, is function times derivative of the natural log of the given function. This is actually not kind of a standard rule or standard result. I just concluded this in this way. Okay, so this is the way, and let me explain what is this step 1 and step 2. While doing these kind of problems, you can follow this step like this. Okay, so step 1, if you have a function like that, y is equal to f of x, what you need to do first, you have to apply log on both sides. Apply log on both sides. Step 2, find the derivative. That's it. Find the derivative means that will be in a differentiable format. You can apply product rule, quotient rule, or whatever it may be. Apply it, simplify it, that will be your result. Okay, so I actually would like to give you some example. I believe that will make more sense. I'm just explaining the theory will not make any sense. I need to show. Okay, that is why I'm going to show you guys one example. Okay, so question: find y dash. We need y dash. Okay, what is the function? Y equal to x to the power of ln x. An interesting function. Condition: x greater than 0. Okay, we can try. What is our step 1? Apply natural log on both sides. apply for the first one or two problem. I will write this, apply natural log. Okay, so ln of y equal to ln of x to the power ln x. Okay. Okay, so we can write this ln y equal to, when we are applying a log on a function, and if it is in an exponential form, that exponent will come in the front of the function, that is this ln x will come in front. So ln x times ln of this x, so I am writing as it is. Now we can write this as ln x times ln x. Okay, log x times log x is ln, because this is natural log, we can write ln square of x. So ln of y equal to ln square of x. So we applied natural log and we simplified as much as possible. Now now find the derivative. Okay, now find the derivative or differentiate on both sides. So what will get ln of y? What's the derivative of ln of y? That is 1 by y. But this is not a function in x. So what you need to do? You have to find the derivative of this function. So that is y dash. We will write that function in the numerator. Okay. What is happening on the other side? Ln square of x. Ln square of x is, so derivative is this, 2 ln x, okay, times, and see, ln x is another function. Ln x is another function. What is the derivative of ln x? 1 by x. 1 by x. Okay. So I can continue the problem here. So this is y dash by y equal to 2 ln x by x, or 2 by x ln x. That is in a good shape. We need y dash. So multiply y on both ends. So this is cancelled out. So y dash is equal to y by x times 2 ln x. If I am the teacher, I will accept this answer. Sometimes some teachers will not accept this, because they will say, this is not the simplest form, so you have to apply this y. What is y? Y is x to the power ln x. So x to the power ln x by x times 2 ln x. There is an opportunity for another simplification, x to the power ln x by x. So this is kind of x to the power m by x to the power n. As we know that x to the power m by x to the power n is x to the power m minus n. So here it is x to the power ln x minus, here the power is 1, so minus 1, times 2 ln x. So that's it. That is your solution for this problem. Y is equal to x to the power ln x and x greater than 0. So that is kind of a base level problem you can expect in your grade level, means in your 11th or 12th grade level. And let me explain another problem. So problem number 2. Y is equal to x to the power cos x, x to the power cos x, and condition x greater than 0. Condition is saying, because if x is 0, the whole scene will change. So nothing is there to differentiate. So we can refresh our memory. What is our first step? We have to apply natural log on both sides. So let me try to use a different color. Okay, so apply natural log on both sides. So ln of y equal to ln of x to the power cos x. Okay, so this is ln of y equal to cos x into ln of x. This is the base rule or the standard rule. If there is a power for the log function, that power will come in front of the function. Nothing complicated there. Now what you can do is you can differentiate. Okay, differentiate it. Okay, this is step 2. So this much, step 1. Now step 2 is going to start differentiation. So this is 1 by y times y dash equal to, you can apply product rule here. You can keep either ln x as the first function or cos x as the first function, no problem. I am actually considering ln x as the first function. So first into, because this is a product, first into derivative of the second. Cos x derivative is minus sin x, so minus sin x. So first into derivative of second plus second into derivative of first. So second is cos x, and the derivative of the first function is ln x, so its derivative is 1 by x. Yep, this is minus sin x ln x plus cos x by x. Okay, so I'm continuing the problem here. So multiply on both sides with a y, so y dash become minus, or I will write the positive term first, cos x by x minus sin x ln x times y, because we multiplied both sides with a y. So the answer is y dash equal to, what is y? X to the power cos x. X to the power cos x times cos x by x minus sin x ln x. So this is the answer. This is the answer. See, if you are following the step 1 and step 2 properly, and if you know the basic facts of differentiation, logarithmic differentiation is kind of a feather. It is very simple. It will not be a hard problem or hard case to deal with. Okay, let me share 1 or 2 more problem. That is the kind of problem sometimes make or create some kind of mental stress. So just y is equal to x to the power arc tan x, and here also the condition we have x greater than 0. Okay, step 1, apply natural log on both sides. So ln of y equal to ln of x to the power arc tan x. Okay, so this become arc tan x times ln of x. So ln of y equal to arc tan x times ln of x. Now step 2 is differentiation. This is step 1. Step 2 is differentiation. So this is 1 by y times y dash is equal to, this is the product arc tan x times ln x. So you can use the product rule, first into derivative of second plus second into derivative of first. So first is arc tan x, first into derivative of second is 1 by x plus second is ln x, derivative of first arc tan x, derivative of arc tan x is 1 by 1 plus x square. This is a standard result that you have to reproduce always through practice. Memorizing is kind of, I will not advise for memorizing something. I will advise you to practice. Practice gives you improvement. Okay, so ln x times 1 by 1 plus x square. You see, we are actually just in the brim of the answer. So y dash is equal to y times arc tan x by x plus ln x by 1 plus x square. So sometimes you can simplify this. What is y? X to the power arc tan x times arc tan x by x plus ln x by 1 plus x square. So this is the solution. Okay, so this is a solution for the logarithmic differentiation. Okay, so these kind of problems are very common in your class level, in your standard level, and if you can practice these kind of problems, the chance you will get more points when you are writing an exam. The practice is actually giving more energy to simplify these kind of problems. This is kind of an easy stuff. So let me give you 2 more problems, and then I'll wind up this session. So another question is y is equal to x the root of x. Sometimes kids may get confused. What is this? This is very simple. Okay, what is x the root means? If you know that basic concept, this question is super easy. So again, follow the basic rule. What is the basic rule? Apply natural log. So ln of y equal to ln of x the root of x. Okay, no problem. What is this x the root means? See, square root of x means x to the power 1 by 2. Correct? Cubic root of x means x to the power 1 by 3. Nth root of x means x to the power 1 by n. Then what is xth root? Xth root of x is x to the power 1 by x. Okay, come here. So this is ln of x to the power 1 by x. This is kind of a format that we did before. If we have an exponent will come in the front. Let me change the color. Okay, so ln of y equal to 1 by x times ln of x. Okay, now apply log on both sides. Now apply differentiation. Okay, or differentiate both sides of the equation. So this is y dash over y. I believe I don't need to explain what is this y dash over y, because this is a log y 1 by y. Derivative log y is 1 by y. Because y is not a function of x, I am taking the derivative of that function also, that is y dash by y is equal to use the product rule again here. What is the product rule? First into derivative of second plus second into derivative of first. First function is 1 by x. Derivative of ln x is again 1 by x. Plus second function is ln of x times derivative of the first. Derivative of the first is minus 1 by x square. Minus 1 by x square. That's good. No problem. So this is 1 by x square. 1 by x times 1 by x is 1 by x square. And here we have a minus 1 by x square ln of x. And now you can take this 1 by x square as common. 1 by x square times 1 minus ln of x. 1 minus ln of x. Oh, that's good. And this is actually this is actually y dash over y. Y dash over y. Okay, y dash over y is equal to 1 minus ln of x over x square. Okay, so cross multiply or just multiply with another y. So your answer is y dash is equal to 1 minus ln of x by x square times y. What is that y? Y is xth root of x times 1 minus ln x over x square. So guys, this is your answer. This is your answer. Celebrate your answer. Okay. This when I'm getting an answer for a question, I usually celebrate because it is actually improving my confidence. That is why I'm celebrating those kind of situation. So finally, guys, I'm going to explain one more problem for you guys, because these kind of problems are most common in your exams. So the final problem of the day: y is equal to sine x to the power cos x. Okay, now usually for these kind of problems we need to consider the domain values and blah blah blah, lot of stuff. But in your grade level, you just need to follow these steps. Apply natural log on both sides, that is ln of y equal to cos x times ln of sine x. I hope you are following me because I skipped one step here. Now you can apply derivative on both sides. That means differentiate both sides of the equation. So this is y dash over y equal to first into derivative of second, that is cos x into 1 by sine x. 1 by sine x. What is the derivative of sine x? Derivative of sine x is cos x. Okay, plus second function ln of sine x into derivative of the first. Derivative of the first is minus sine x. So this is cos x by sine x is cot x. So cot x cos x minus sine x into ln of sine x. That's kind of a good answer, but not completed, because we need y dash means times y. So we know that this times y is sine x to the power cos x. So your answer is cot x cos x minus sine x into ln of sine x times sine x to the power cos x. So this is your answer. This is the answer for the final question of the day. So I believe all of you enjoyed this session, and I believe you are actually following my videos. If you wish to get the videos of the same kind or any mathematical topic that you are thinking, please subscribe my channel and don't forget to press the bell icon. And please share this channel and these videos to your friends and relatives so I can help them too. Thank you very much guys. Thank you. I will come back with another video soon.